My name is Simona Errico. I am a biologist and I work in ENEA Trisaia Research Center. ENEA is the Italian National Agency for New Technologies, Energy and Sustainable Economic Development. It is the second public research body in Italy, and it has 9 research centers in all around the country. And Trisaia Research Center is in the south of Italy in a region named Basilicata. My speech today is about Tenebrio molitor as new interesting protein source. I know that it is a little strange speak about an insect to a food science and nutritional conference, but just insects represent a new promising alternative source of protein for human food. So, and especially Tenebrio molitor. And so let's know this insect better. Tenebrio, sometimes I'll say TM for Tenebrio molitor. Tenebrio molitor is a beetle in a Tenebrionidae family, also named mealworm or yellow mealworm, with a life cycle of 4 or 5 months and 4 steps: eggs, larvae, pupae, and adults. It is well adapted to different environmental conditions, but as rearing conditions, it prefers these ones. Especially, it prefers darkness. So, in the photo period, the light hours are not included. After the FAO report in 2013 that suggests insect as a new alternative source of protein, there were many studies that attested the total sustainability of Tenebrio molitor rearing because of many advantages: less greenhouse gas emissions, lower energy and water consumption, and so on. Nowadays, after about 10 years, we know that it's true, but only certain conditions, especially if we consider a large-scale rearing and about a supposed low energy consumption that is not so lower. Compared with traditional breedings, Tenebrio molitor is a good choice because of many parameters, especially a good conversion efficiency. That is a very strong point of this insect. On the other hand, Tenebrio molitor has a very interesting nutritional profile, comparable in many respects to the pork, but higher in iron and much higher in calcium. The only downside is the calories, because they are significantly higher than its competitors. From Tenebrio molitor larvae, it's possible to obtain many proteins and peptides with a positive effect on human health, and oil very interesting for its properties. 2 molecules, chitin and chitosan, that are mainly used in cosmetics and in biomedical applications. Flour, both used in human food and animal feed. And from Tenebrio molitor rearing, not larvae, it's possible to obtain frass that is used to replace the mineral fertilizers. There are also many studies that are investigating a possible role of Tenebrio molitor in a plastic biodegradation, and other studies that attested its role in fast recovery. My speech is about flour because it's the main product used in human nutrition. Several proponents have applied to European Commission for approval to use flour from 7 different insects. 4 for using larvae and 3 for using adults. Tenebrio molitor is the first insect approved by European Commission as novel food, and at the moment is the only one approved for using larvae. The other 2 insects approved more recently are approved for using adults. As a source of proteins, Tenebrio molitor competed with another insect, Hermetia lucens. Hermetia lucens is also named black soldier flyer because the shape of adult seeds is similar to soldier helmets. It is a different insect because it belongs to another order, it's a Diptera, but it has a nutritional profile and a life cycle similar to the Tenebrio molitor ones. The difference is that Hermetiae lucens adults fly, while Tenebrio molitor adults don't fly. But the most important characteristic is what they can eat, because Tenebrio molitor is an omnivore that prefers grains, while Hermetiae lucens is a scavengers that can feed on any waste. From an environmental point of view, this is a good characteristic because we have an insect that can feed on any waste. But when we consider the possibility to use its larvae for human food, this is not good. In fact, this held back its approval for human nutrition by European Commission, while Tenebrio molitor is already approved. So, are we going to eat insect-based food? Yes, it's very likely. After the approval of Tenebrio molitor as a novel food, there are many companies that are introducing Tenebrio molitor flour among their ingredients. In Italy, at the moment, there is only one company that produces snack, pasta, and biscuits, and just in these days, cookies, both white and cocoa cookies. Online, it's possible to find many products made by insect flour, but they are mainly made by cricket flour, even if its approval is more recent. However, for a daily consumption of Tenebrio molitor flour in our food, there are many challenges to be faced. The first is sustainability, and the keywords is valorization. From a circular bioeconomy point of view, Tenebrio molitor represents a good tool because it's possible to valorize not only the food lost in waste and the substrates that became its feed, but also what a lot of we can obtain from its rearing. But how to choose the best food loss and waste for Tenebrio molitor larvae? We have to pay attention to some factors. Substrates have to be cost effective and of high quality. Of course, they have not be contaminated. They have to be available in any season and correctly stored, because they are often rich in water, and so they easily can become putrescent or mold. Then it's better to choose substrates that don't require pretreatments and that aren't used for human food or animal feed. On the other hand, using food loss and waste for Tenebrio molitor larvae has some advantages because they are present in large quantities and with great diversity. The consumption of Tenebrio molitor as food is growing to meet the human request, the human need of proteins, and it's possible to place Tenebrio molitor rearing near the substrate suppliers, so reducing costs. Another challenge is the allergens, because Tenebrio molitor, like other insects, has a protein, tropomyosin, that is the same of shrimps. So people allergic to shrimps may be allergic to Tenebrio molitor as well. About food safety, there are many aspects related to this to it, but I don't examine all of them in this slide. I give you only some spots. For example, about rearing condition, we know that we need of controlled hygienic conditions and reliable and accurate methods of analysis. A possible gut contamination can be faced with larvae fasting, as well as a surface contamination can be solved by heat treatments. We know that Tenebrio molitor is able to accumulate selenium, and this is good. But there are many studies about the ability to accumulate heavy metals or mycotoxins that not is very good. Then there are also many studies ongoing about the contamination by microorganisms. At the moment, we know that hepatitis A virus, hepatitis E virus, and the norovirus of growth through are not present in the Tenebrio molitor rearing. Last but not least challenge is the consumer acceptance. In Western countries, insect-based food induces disgust or phobia, and insect consumption is often associated to times of crisis or catastrophes. It's generally perceived as distant from Western food culture, while in the other part of the world, insects are the usual food of many peoples. However, some studies and an IPIF report attested that this is changing because Western consumers are getting used to the idea of eating insect as long as they are not present, not visible in the plate, and they are fully processed. In our laboratory, bioproduct and bioprocess laboratory, we study Tenebrio molitor from different point of view. In the basic activity of rearing, we analyze the effect of waste and bioproducts inclusion in the rearing diets and the change of some rearing condition on some growth parameters. We added to it the development of a process for obtaining the fatted flour, so the fatting flowers, which can be stored for a long time and which we use for studies, collaboration, and tests. We add to it the development of a sustainable process for extraction of chitin from exuvi of Tenebrio molitor, and the evaluation of advantages of using frost in the cultivation of local vegetable species. Finally, for more, if anyone would like to deep this topic, I can suggest these 3 reviews that our group, working group published on the last year, in which we describe Tenebrio molitor from different perspectives, especially from a circular bioeconomy point of view. Finally, I would like to introduce you the team that works with the Tenebrio molitors. I give you some useful links, and I would like to thank you very much for your attention.